will come under the kinematics part, okay, kinematics of machine, and just we'll see what are different types of gears and what are the different things that will be involved in this. Okay, so for this unit 3 we have two chapters, one is gear and then extension of this gear we have gear train. Okay, so two topics are there in this. So let us first understand what is a gear. Okay, so gear is a wheel with having the teeth, so that mesh together with other gears. So just now you told this thing. Okay, so in this gears actually had a different operation with respect to change the speed, then torque or direction of the rotating axles. Okay, so for all this purpose a gear is used. So the gear is nothing but a power transmission, used for power transmission. So applications of gears can be seen in different toys and small mechanism, where you can see it is for small low load and low cost use for the kinematic analysis. And appliance gears also there, which is having for long life, low noise and cost, and low to moderate load can be applied to this. Kinematic and some stress analysis can be done on this. And power transmission, that is for long life, high load and speed. So here also can do the kinematic and stress analysis on this. And aerospace gears, they should be lightweight because it is used for aerospace, so lightweight, and then moderate to high load should be there. And again kinematic and stress analysis can be performed on this. And control gears, again for long life, low noise and precision gears. So kinematic and stress analysis can be performed on this. Then we have different types of gears, like if you consider the position of the axis of the shaft, that is parallel. So you have spur gear, then helical gear and rack and pinion. And intersecting type you have about the bevel gear. So you have seen the different gears also, so you know the things. Okay, and based on non-intersecting and non-parallel, you have seen worm and worm gears. Then we have spur gears. So spur gear will be having a tooth profile which is parallel to the axis of rotation and transmits motion between the parallel shafts only. You can see in the figure a gear and pinion. A gear will be a larger gear and a pinion will be the small gear there. So one will have the rotation motion and other will automatically will be driven by that. And also a type of internal gears are also there. So the first figure you see about the external gear contact. Now you can see the figure with the internal gears. Then we have about helical gears also, so which are where the teeth are inclined to the axis of rotation, and the angle provides a more gradual engagement of the teeth during the meshing and transmits the motion between the parallel shafts. Okay, so you can see the small change in the angle, that teeth which are there that are inclined to the axis of rotation, that is the only change. Otherwise the it will be parallel alignment with respect to shaft only. Okay, so if you consider now the directions, okay, external gear, what will happen if one wheel is having rotation in clockwise, automatically the other gear, that is pinion part, automatically will be in opposite direction. Okay, that will be, if one is in clockwise, automatically other will be in counterclockwise. Okay, whereas in internal gear, what will happen? Internal gear, if one is having the rotation in clockwise, other gear will have which direction? Can you think and tell me? Anyone? See the figure there. External gear arrangement is also there and internal gear is also there. Can you anyone tell? Internal gear, if one is having in clockwise, other wheel will have which direction?
Sir, clockwise only, sir.
So that is the thing you have to remember. So in external gear, what will happen? The driver and driven both will be opposite direction. Whereas in internal gear, both will have the same direction. Okay, this will be very useful when you do the gear train. Okay, that time while solving the problems, you should understand this. Okay, so these are the different types of gears that we are seeing now. So teeth is parallel to the axis of rotation in spur gear and transmit power from one shaft to another parallel shaft, and it is used in electric screwdriver or oscillating sprinkler, wind up alarm clock, washing machine, and clothes dryer. Many applications for gear. Each and every day, I think of in every machine you are using, you will be seeing this help of a gear. So a driver will be there, it will be having the one rotation, and the driven will be opposite direction. Okay. Then external and internal gear, you can see just now I showed you external and internal gear. So next we will see about helical gear. So the teeth on helical gears are cut an angle to the face of the gear. So this gradual engagement makes helical gears operate much more smoothly and quietly than the spur gears. And one interesting thing about helical gear is that if the angles of the gear teeth are correct, then can be mounted on perpendicular shafts and adjusting the rotation angle by 90 degree. So this is the arrangement for a helical gear. You can see the angle, the teeth are being cut at an angle of that whatever angle will be given there. Then herringbone gears are also there. So to avoid axial thrust, two helical gears of opposite hand can be mounted side by side to cancel resulting thrust forces. There you can see that figure. So herringbone gears are mostly used in on heavy machinery. So very heavy machinery is required. There you can use this herringbone type of gears. Next we can see about the bevel gears. Okay, so again in this what will happen, the teeth are formed on a conical surface used to transfer motion between non-parallel and intersecting shafts, but non-parallel. Okay, so this is the figure. You can see the straight bevel gear there, and one more thing, you can see the spiral bevel gear. Okay, again bevel gears you have straight also and spiral also. You can see the figure where straight bevel gear having the teeth exactly straight manner, whereas in spiral you can see that is having this little bit curved nature. Okay, so again both type of bevel gears can be seen here. So bevel gears are useful when the direction of the shaft rotation needs to be changed. Automatically can change the direction. You can see how the alignment is there for this. So automatically is perpendicular. So they are usually mounted on the shaft that are 90 degree apart. So that is always perpendicular, but can be designed to work at other angles also. So small changes also you can do. And the teeth on bevel gear can be straight, spiral or hypoid. Okay, and used in locomotives, marine applications, automobiles, printing presses, cooling towers, power plants, steel plants, railway track inspection machines, etc. So used in many places. Even in your automobile, many places you can see the bevel gears are used. Okay, mainly in the differential part also you can see bevel gears are used. Okay, next these are the straight and the spiral bevel gears. Then we see about the worm gear sets here. So consists of a helical gear and a power screw. So used to transfer motion between non-parallel and non-intersecting. So worm gear is completely non-parallel and non-intersecting. You can see there. So rack and pinion sets, a special case of spur gears with the gear having an infinite large diameter on the teeth are lead shaft. So can you tell the example of a rack and pinion? Anyone? Where have you seen the rack and pinion?
Here.
Yes.
Like Tata Hitachi.
Tell me the exact application. Don't tell
Lathe, sir,
company.
lathe.
Yes. So when you move the lathe carriage, automatically you want to rotate rotary motion into convert it into linear, right? You lathe, what you do, the rotary motion is being used there by your hand, and automatically will have the linear. So you can convert the rotary motion into linear by using this pinion. It is going to slide over the rack. Okay. So like that, different gears will be helpful. So you can see how the alignment will be there for worm and worm gear. So worm gears are used when large gear reductions are needed. So it is common for worm gear to have reduction ratio of that is 20:1 and even up to 300:1 or greater can be used. Okay, many worm gears have an interesting property that no other gear set has. The worm can easily turn the gear, but the gear cannot turn the worm. Okay, that is only the problem here. And worm gears are used widely in metal handling and transportation machinery and machine tools, automobiles, etc. So used in many applications. So rack and pinion gears are used to convert rotary motion into linear motion. So that is from the pinion to the rack. So example can be nothing but a steering system on many cars. Again, that is also one of the example. Next we'll come to the nomenclature of the spur gear. Okay, so this is very important to understand the nomenclature of this. Okay. So you can see the first, this is the base circle. Okay, always the base circle is very important for that. And you can see the pitch circle exactly will be at the center. So when the teeth is considered, and exactly at the center of that teeth, if you take the pitch circle will be there, and the lower part will be having the base circle. Okay, and the top part automatically will have the addendum circle. Okay, and same way lower bottom will be having the dedendum circle. Okay, and this entire width of this teeth is given as face width and given by small b, and it also the top face is known as the top land, and the side face is known as the face. Okay, and the lower portion of this known as the flank. Okay, and the tooth thickness can be measured only on the circular pitch, taking the center distance from this, that is the from the pitch circle only, that is circular pitch which is there here. On this whatever this pitch circle, you can calculate the dimension here. So the width can be calculated, the entire the tooth, this one can see the total distance from here to here, can also be calculated, and the top portion is calculated by T0. So this thickness will be different, and this is the width of space. So if the gap is there, that gap is also calculated as given as the width of space. Okay, so like this, and the lower bottom you can see some clearance also there to give some clearance when the another gear is going to mesh over here. So you should have some clearance. So clearance is given here, and this is the fillet radius that is provided there. So the distance from the pitch circle to the top side is known as the addendum, to the addendum circle. So top side you can see this is the addendum circle. Okay, so from the distance measured from the pitch circle to the addendum circle is known as addendum, and the distance from pitch circle to the lower part, that is known as the dedendum. And total distance addendum plus dedendum is known as the whole depth, and without clearance it is nothing but the working depth, because the whole depth is included with the clearance. And the backlash is also calculated if there is error. So tooth spacing, that is driven gear minus tooth thickness of the driver, if you measured on the pitch circle, that will be having to give the backlash. Okay, so the things what we discussed now. So pitch circle, pitch surface is nothing but the surface on of the imaginary rolling cylinder that tooth gear may be considered to replace, and pitch circle is the right section of the pitch surface there, and addendum circle is circle bonding the ends of the teeth in a right section of the gear, that is on the top side, and dedendum circle it is at the bottom side, and addendum, the radial distance between the pitch circle to the addendum circle top side, and addendum dedendum, the distance from the dedendum circle to the pitch circle, whatever distance is there, and clearance is nothing but the difference between the dedendum of one gear and addendum of the mating gear, that can be clearance. Then face of the tooth, the part of the tooth surface lying outside the pitch surface, and flank of the tooth can be the part of the tooth surface lying inside the pitch surface. And circular thickness also can be calculated, known as also the tooth thickness, and it can be measured on the pitch circle. So just now we seen it is the length of an arc, but and not the exact length of the straight line. So that is a tooth thickness. Then tooth space is also there, that is a pitch diameter, the distance between the adjacent teeth measured on the pitch circle. And backlash, just now we saw that the difference between the circular thickness of one gear and the tooth space of the mating gear. And pitch circular pitch also can be calculated, that is nothing but the width of the tooth and the space measured on the pitch circle, that is pi d divided by t. So the entire pitch, circular pitch will be from this distance, from the start of the tooth on the pitch circle on this one point to the thickness plus the width of the space. Total distance is known as circular pitch. It is shown here. So this entire circular pitch, small p, that is from the entire length of this. Then the diametrical pitch, so the number of teeth of a gear unit, pitch diameter. So diametrical pitch is nothing but the number of teeth divided by the pitch diameter. So that is t by d. So module also you know. So diameter, pitch diameter divided by the number of teeth, you will be getting the module. So that is a d by t. And pitch diameter is usually specified in inches or millimeters. In the former case, the module is the inverse of the diametrical pitch. And how to calculate the velocity ratio? So you know that velocity ratio is nothing but the ratio of the speeds. Okay. So if you take omega 2 by omega 1 or n2 by n1, or nothing but d1 by d2 is nothing but the same thing what we will be getting for the velocity ratio. Okay. So fundamental law for the gears can be seen here. So that we will be discussing later part. So we don't have to discuss much. There are again standard two specifications are also there for the consideration. Okay, not discuss much of the related to the dimension part. This all things will be under the design part. Okay. Okay, then we can discuss with the gear trains also. So after the gears topic, we will be discussing about the gear trains, where the one gear is connected with more than 2, 3, 4 like that. N number of gears can be connected to form a gear train. Okay, so that we can see later part in the next topic when we start with the gear trains. Again, there are different types of gear trains, like a conventional, planetary, and different sun and planet type of gear trains. So different gear trains can be seen there. Okay. So we'll stop here. This is only the basic introduction about the gears.